Going on here. Okay, I rewrote it to be more clear on a separate sheet of paper. If you need more room, then just ask on the test. Here is my distance of the satellite above the Earth, but I'm going to have to do this all in meters because otherwise it doesn't cancel with newtons. So this is adding 3 zeros as meters, and looking ahead I need to add it to the internal radius of the Earth, and it was expressed in E6 meters times 10 to the 6 meters. So I'm going to put this in times 10 to the 6 meters so that they add properly, even though that's not true scientific notation, but it's still the same information, so we don't really care. When I add these, of course, I get this. This is the distance from the core of the Earth to the satellite. You have to measure from the core of the Earth, not from the surface of the Earth. So here's our velocity of a satellite around an orbited body. It's on the equations page, of course. Here's G, our gravitational constant. Here's the mass of the Earth, which is just a given, also given in the equation and constants page. And here's the distance from the core of the Earth that I calculated before. Please follow this one and not the one on the Fakie, as the decimal got off. This times this divided by this, and square root of that answer should give you 2,451 meters per second. So time of a satellite in orbit is, again, on the equations page, is equal to 2 pi. And again, the r is the radius of the orbit above the core of Earth. So again, we're going to use that number that I calculated here times over the gravitational constant and the mass of the Earth. So here's the distance from the satellite to the core, cubed, the gravitational constant, and the mass of the Earth. This cubed gives me this number, and the meters are cubed. This times this gives me this number, and one of the kilograms cancels out. I have gone ahead and looked at all the units, and I am convinced that they actually do cancel out to seconds squared, by the way, down here. If you want to talk about it, come up to me. It's a bit of a hassle, or you can just believe me. This divided by this should give you this in seconds squared. When I square root that, I get this number, and of course this squared comes off the seconds. Times 2 pi gives me this. That is in seconds. That's not very useful. Most people don't know what to do with thousands, tens of thousands of seconds. So we're going to divide by 3,600. Divide by 3,600 to give us hours.